Right now, Chevy owners are spending $6,000 on emissions repairs for sensors that aren't even broken, just dirty. One contaminated sensor can steal 18% of your power and kill your fuel economy without a single warning light. Today, I'm sharing 10 sensors that fail the most that only require cleaning. Don't skip number 3. It causes the most expensive failures. Number 1. Sensor connectors and wiring harnesses. This is where the most money gets wasted, and it's the first place experienced Chevy techs check, even though dealerships rarely do. Not because it's complicated, but because diagnosing wiring isn't profitable. Every sensor in your Chevy depends on 3 things: clean power, solid ground, and an uninterrupted signal path to the ECU. Over time, engine heat, vibration, moisture, and road salt attack connectors and harnesses long before sensors themselves actually fail. Pins oxidize, grounds loosen, wires break internally while the insulation still looks perfect. Here's the chain reaction. Corrosion adds resistance. Resistance distorts voltage. The ECU reads bad data and compensates by changing fuel, timing, or shift logic. Now the engine runs rich or lean. The transmission shifts oddly, and fault codes point to sensors that are actually fine. Shops replace parts because it's fast. Owners spend $1,000 to $3,000 chasing ghosts. I've seen sensors fail on scan tools, then test perfectly on the bench. The real culprit was green corrosion inside a connector or a weak ground. Hot take. Manufacturers call these connectors lifetime. In real-world driving, that's nonsense. Cleaning terminals with CRCQD electronic cleaner costs under $30 and fixes issues that mimic catastrophic failures. Very often, your Chevy isn't failing because a sensor died. It's failing because the information can't get out. Number 2. Vehicle Speed Sensor, VSS. This sensor is responsible for some of the most expensive false alarms in Chevy trucks. When shifts start feeling harsh, delayed, or inconsistent, the transmission immediately gets blamed. I've seen owners mentally write off $4,000 to $6,000 before anyone even checks this part. The Vehicle Speed Sensor, VSS, feeds the ECU real-time road speed data. That single input controls when gears change, how long the torque converter stays locked, when fuel cuts on deceleration, and whether cruise control stays engaged. If that information is wrong, everything downstream unravels. What actually causes the failure isn't electronics dying. It's contamination. Metal shavings, oil residue, and road debris cling to the magnetic pickup. The signal becomes unstable. The ECU thinks the truck is speeding up and slowing down erratically, even on a smooth road. The consequences stack fast. The transmission begins searching for gears. Converter lockup cycles on and off. Fluid temperature rises. Once heat builds, clutch material starts shedding. That debris circulates, making the problem worse. At that stage, the transmission really is in trouble, but it didn't start there. Most shops skip this check and go straight to transmission diagnostics. Cleaning the sensor and connector costs less than $20 and takes minutes. I've watched vehicles arrive on a flatbed and leave under their own power the same afternoon. This isn't a transmission problem, it's a data problem that snowballs. Number 3. Oxygen Sensor, O2/Lambda Sensor. This is the sensor that quietly fails the most tests, wastes the most fuel, and drains the most money, and it almost never gets blamed early enough. Across emissions data, a huge share of failed Chevy tests come from oxygen sensors that are slow, not dead. Here's why that matters. The O2 sensor is the ECU's feedback loop. It tells the computer whether combustion was rich or lean, so fuel delivery can be corrected on the next cycle. When the sensor is healthy, that adjustment happens in milliseconds. When it's contaminated, the signal lags. That delay changes everything. The ECU keeps correcting fuel after combustion instead of before it. Fuel trims swing wider, power drops, fuel economy falls off a cliff, emissions spike, and because the sensor still produces voltage, there's often no fault code to point anyone in the right direction. What contaminates them is predictable: oil consumption, fuel additives, silicone from sealants, and long oil change intervals. Once the sensing element is chemically poisoned, cleaning only helps briefly, if at all. This is where owners get crushed financially. Shops chase rich and lean conditions, replacing injectors, coils, and catalytic converters. I've seen invoices between $1,200 and $3,000 before the oxygen sensor is finally addressed. Replace it too late and the excess fuel overheats the catalytic converter next. That's another $1,500 plus problem. This isn't a sensor you wait and see on. It's one that quietly turns a healthy Chevy into an emissions nightmare. Number 4, knock sensor. This is where performance disappears without anything ever breaking. No warning lights, no hard codes, just a Chevy that slowly starts feeling heavier and weaker every year, until owners assume its age. That assumption is expensive. The knock sensor is bolted directly into the engine block and listens for specific vibration frequencies caused by detonation. When it hears knock, the ECU immediately pulls ignition timing to protect the engine. That part works incredibly well, almost too well. Here's the real issue. Dirt, oil residue, corrosion, or improper torque on the sensor changes how it occurs. Instead of detecting real knock, it starts picking up false vibration. The ECU reacts defensively and retards timing constantly, even when combustion is perfectly clean. What that does downstream is brutal. Timing gets pulled, cylinder pressure drops, torque falls off, throttle response dies. I've dyno tested engines down 15 to 25 horsepower with 0 fault codes, all because the ECU thought the engine was knocking when it wasn't. Owners get told the engine is tired or carboned up. Quotes start at $4,000 plus for engine work that isn't needed. Meanwhile, the real fix is simple. Cleaning the mounting surface, ensuring proper torque, and eliminating corrosion restores accurate knock detection. When timing comes back, power comes back immediately. GM calls this normal performance degradation. In real shops, it's a sensor lying loudly enough to steal horsepower quietly. Number 5. Manifold Absolute Pressure Sensor, MAP. This sensor is responsible for some of the worst fuel economy losses I see in Chevy trucks, and most owners never connect the dots because the engine still feels strong. No misfires, no warning lights, just a fuel gauge that drops way faster than it used to. The MAP sensor tells the ECU how hard the engine is working by measuring pressure inside the intake manifold. That single input is used to calculate engine load, fuel delivery, and ignition timing. When the reading is accurate, the engine runs efficiently. When it isn't, the ECU makes terrible decisions with confidence. Here's what actually goes wrong. Carbon buildup clogs the MAP sensor port. Vacuum hoses develop tiny cracks. Oil vapor coats the sensor diaphragm. The pressure reading becomes skewed. The ECU now believes the engine is under heavy load all the time, even during light cruising. The response is predictable. Fuel delivery increases. Timing gets safer. Fuel trims climb. Owners lose 4 to 6 miles per gallon and assume it's just a truck thing. Then the misdiagnosis begins. Injectors get blamed. Fuel pumps get tested. Catalytic converters get mentioned. I regularly see quotes between $2,000 and $4,000 before anyone even looks at the MAP sensor. Cleaning the sensor and inspecting the vacuum line costs under $20 and takes minutes. Once corrected, fuel trims normalize almost immediately. Ignore it long enough, and that excess fuel overheats the catalytic converter next. That's when a simple sensor issue becomes a 4-figure emissions repair. Number 6. Crankshaft Position Sensor, CKP. This is the sensor that makes people think their Chevy is about to strand them for good. Random stalling. Long cranks when the engine is hot. Sudden shutdowns at traffic lights followed by a perfectly normal restart 5 minutes later. I've seen owners lose confidence in otherwise solid trucks because of this one part. The Crankshaft Position Sensor, CKP, tells the ECU exactly where every piston is and how fast the crankshaft is rotating. That information controls spark timing and fuel injection down to the millisecond. When the signal is clean, the engine runs flawlessly. When it's distorted, everything unravels fast. What actually causes the issue isn't electrical failure. It's contamination. The magnetic tip of the sensor attracts metallic debris, burnt oil residue, and fine sludge over time. That buildup weakens and distorts the signal. The ECU briefly loses crank position reference, even if it's only for fractions of a second. From behind the wheel, that feels like misfires, hesitation, or the engine simply dying with no warning. Shops often go straight for fuel pumps, ignition modules, or even timing components. Quotes usually land between $1,200 and $2,500, and the problem often comes back. Cleaning or replacing the crankshaft position sensor takes about 15 minutes. Ignoring it doesn't just cause inconvenience. Those momentary misfires dump raw fuel into the exhaust, overheating the catalytic converter. That's how a $50 sensor quietly sets up a $1,500 emissions failure. This isn't an intermittent mystery. It's bad position data cascading into very real damage. Number 7. Camshaft Position Sensor, CMP. This is one of the most consistently misunderstood sensors in Chevy engines, because the failure doesn't stop the engine. It just makes it behave badly enough to send owners down the wrong diagnostic path. The Camshaft Position Sensor, CMP, tells the ECU which cylinder is on its firing stroke. That information controls sequential fuel injection and valve timing. When the signal is clean, the engine idles smoothly, starts easily, and responds predictably. When it's not, the ECU loses precision. What causes the issue almost every time is oil contamination. Sludge and oil mist coat the sensor face, especially on engines with longer oil change intervals or active fuel management systems. The signal weakens. Instead of clean, consistent pulses, the ECU gets fuzzy timing information. The computer reacts by dropping into a fallback strategy. Injection timing becomes less precise. Idle quality degrades. Cold starts take longer. Hesitation shows up right where people drive most, around 2,000 to 3,000 RPM. At higher RPM, the problem often feels less noticeable, which makes diagnosis even harder. Here's where money gets wasted. Shops chase misfires, coils get replaced, injectors get cleaned. I've seen $1,000 to $2,000 spent before anyone checks the cam sensor. Cleaning or replacing the sensor is straightforward and inexpensive. Fix it early, and the engine immediately feels sharper and smoother. Leave it alone, and that inconsistent combustion loads up the catalytic converter next. That's when a drivability issue quietly becomes an emissions problem. Number 8. Engine Coolant Temperature Sensor, ECT. This is one of the most damaging sensors to ignore because when it lies, the ECU builds the entire fueling strategy on bad assumptions. And GM's guidance around coolant service is a big part of why this fails so often in the real world. The Engine Coolant Temperature Sensor, ECT, tells the ECU whether the engine is cold, warming up, or fully hot. That single input controls cold start enrichment, idle speed, fan operation, and ignition timing. If the sensor reports the engine colder than it really is, the ECU keeps enriching fuel long after it should stop. Here's what actually causes the failure. Old coolant breaks down, additives deplete, scale and corrosion build up on the sensor tip. On paper, the sensor still works. In reality, it responds slowly and reports the wrong temperature. The downstream effects stack up quietly. The engine runs 8 to 12% rich during normal driving. Fuel economy drops. Idle quality suffers. Oil gets diluted with fuel. Cylinder walls lose lubrication. Ring wear accelerates. Owners then chase the symptoms. Spark plugs foul. Coils get blamed. Injectors get tested. I routinely see $1,500 or more spent before anyone questions the temperature data the ECU is trusting. Cleaning or replacing the sensor is cheap. Flushing degraded coolant restores accuracy immediately. And here's the funny part: long life. Coolant intervals look great in brochures. In real shops, they quietly shorten engine life by letting the sensor lie for years. Number 9. Throttle Position Sensor, TPS. This sensor gets people into trouble because the symptoms feel mechanical, not electronic. Hesitation right off the line, a dead spot at light throttle, sudden surging at steady speed, and almost every time it gets blamed on the transmission. That mistake is expensive. The Throttle Position Sensor, TPS, tells the ECU exactly how much throttle you're requesting, down to fractions of a degree. The ECU uses that input to decide fuel delivery, ignition timing, torque management, and shift behavior. When the signal is clean, the engine responds smoothly. When it isn't, the ECU constantly second guesses itself. Here's what actually goes wrong. Inside the sensor is a resistive track that wears most at the throttle angles you use every day. Light acceleration and cruising. Add carbon buildup on the throttle plate and airflow no longer matches throttle angle. The voltage signal drops out or spikes for milliseconds. The ECU reacts instantly. Timing gets pulled. Fuel delivery jumps. Torque management intervenes. From the driver's seat, it feels like jerking, hesitation, or sudden power loss at very specific pedal positions. Shops often replace the entire throttle body, quoting $600 to $900, or worse, blame internal transmission issues. In reality, cleaning the throttle body with CRC throttle body, an air intake cleaner, and verifying smooth TPS voltage usually fixes it. That's a $15 service preventing a repair bill that makes people consider selling the truck. Ignore it long enough, and that unstable throttle signal starts stressing the transmission next. What began as a drivability annoyance turns into a real hardware problem. Number 10. Intake Air Temperature Sensor, IAT. This is one of the most ignored sensors in your Chevy, and that's exactly why it causes so much slow, expensive damage. The IAT sensor doesn't just monitor air temperature. The ECU uses this data on every combustion cycle to calculate air density and decide how much fuel to inject. Here's the problem. On most Chevy engines, especially 5.3 liters and 6.2 liters V8s, oil vapor from the PCV system constantly flows through the intake. Over time, that vapor coats the IAT sensor. If you're running an oiled aftermarket air filter, contamination happens even faster. The sensor doesn't fail electrically, it just starts lying slightly. The ECU now believes intake air is hotter than it actually is. Hot air is less dense, so the ECU trims fuel. That leans the mixture under load, dulls throttle response, and increases knock activity. To protect the engine, the ECU pulls timing. Power drops, fuel economy suffers. GM calls this normal adaptation. In real shops, it's avoidable. Owners usually notice losing 2 to 3 miles per gallon and sluggish acceleration. They get quoted $300 to $500 in diagnostics chasing fuel or ignition issues. Meanwhile, cleaning the IAT with CRC mass airflow cleaner costs under $10 and takes 5 minutes. Ignore it long enough, and lean operation increases combustion temperatures. That accelerates carbon buildup on pistons and intake valves, setting up real engine damage later. This isn't a minor sensor. It's a small liar that quietly rewrites your fuel map every time you drive. If this just saved you from a 4-figure repair bill, don't wait. Subscribe now, because the next video covers mistakes that kill Chevy engines fast. And comment which Chevy you drive. The next breakdown could be yours.